Well, with
knowing doing it.
Yep. Well, with a car, you need to deal with the hot exhaust pipes and the engine, the motor oil and stuff like that. In programming, you don't have the physical aspect of getting your hands dirty, but you still have to wrap your mind around the problem, and sometimes you have to soak a few days to even get a good understanding of the nature of the problem.
Finding that one semicolon that you missed.
The semicolons are not as much of a problem because they are tools to find those problems. The problems are, okay, should you use greater than, or should you use greater than or equal to as a comparison? Those are the typical problems that a programmer has to deal with. It's usually marginal. The program works for the most part, but it does not work for a few cases. Okay, so then you have to find out why is it not working for those few cases. Okay, and we'll talk about the traits of a typical programmer later on too. So we'll deal with that also. Okay, and then the last part is testing. A test engineer is a person whose only job is to check whether a program or a system behaves the same way as it is specified in, say, quote unquote, the blueprints. Okay. Now, why don't we just ask the programmers to do the testing?
Because they already know how it's supposed to work, and that's the way they'll see it. It'd be harder for them to notice a discrepancy.
Exactly. If they knew, let's say the program does not work the way it's supposed to, if the programmers knew that the program is not working the way it's supposed to, they would not have written the program like that to start with. Okay? So a lot of times, the programmer will write the program according to their understanding of the specifications. If they miss a point, they miss a point. They miss a point reading the documentation, and they will miss the same point when they write the program. When you ask them to test the program, they will miss exactly the same point. So that's why when you test the program, you don't rely on the same people who actually wrote the program. You rely on a separate group of people called test engineers to test a system. Okay? So what these people would do, what a test engineer would do, is to go back to the blueprint. Okay? And they will say, okay, this is the expected behavior of the program, and I will test the expected behavior using that documentation. They will not even look into the program itself. They will just test the program according to the description of how it is supposed to behave. So these are the different roles in software or system development that are useful to a developer. The developer is basically in the middle, actually writing the programs. So now we can start to talk about algorithms. When was the first time you have heard of this term algorithm?
In math.
In math? That's algorithmic. That's the log of something. That's not the same thing as algorithm. Okay? Most people come in contact with this term from Star Trek.
Tron.
Tron?
Yeah. It was in
The first one?
no,
The new one? Okay. Yeah, because I don't remember the old one, refer to algorithm. They had operating systems, but not, algorithms. Well, an algorithm is basically a fancy term to refer to a method to complete a particular task. Okay. In other words, you can just look at it as a fancy word of method, a way of doing things. For example, there's an algorithm to sort a deck of cards. Okay, you give me a deck of cards that is out of order. There's a method to do it systematically to sort the deck of cards. What makes an algorithm different from methods? Well, when you look at an algorithm, it is usually very precise. In other words, when you read an algorithm, there should be no ambiguation. There should be no two way to interpret the same sentence. Why would that be bad when you specify an algorithm, when there are two ways to interpret the same sentence?
Think of most conditions are tested as being true or false, so it would be both.
Right, because some people can look at it one way and say, okay, this is the way I interpret this statement, and I write the program according to this. and then the next person who is documenting the program will interpret it the other way. So now you have a discrepancy between the documentation versus the actual behavior of the same program. But neither is wrong, it is just a different interpretation of an ambiguous statement. So ambiguation is bad when you're talking about programming. An algorithm is also very specific. In other words, there's no such thing as a multi-tool algorithm. A algorithm solves a specific problem. Okay? Most universities have a high upper division class called algorithm analysis, or the analysis of algorithms. This class, cisp300, is basically, those classes, analysis of algorithms, are basically math classes that will analyze algorithms for correctness and also for efficiency, which is not something that we will deal with in this class. And we'll talk about pseudocode just a little bit. There are many ways to represent an algorithm, and most of you probably know what is a flowchart. Yes? Kind of? Okay, a flowchart tells you how to do something because it's a picture. Okay, you start from the beginning, and then the arrow points to the next step, and then from that it will point to the next step. When you see a diamond, you make a decision. So we'll ask you a question. If the answer is yes, go this way. If the answer is no, it goes the other way, and so on and so forth. So that's one way to represent an algorithm. But in this class, we don't use flowcharts. Okay? We use flowcharts only at the very, very beginning so that people can get a graphical representation of algorithm. But other than that, we'll use pseudocode. So what exactly is pseudocode? Well, okay, let me just kind of go back here a little bit here and explain why I do not use flowcharts. There are two big problems with flowcharts. The first problem is, structurally speaking, flowcharts are bad. Because with a flowchart, you can always just add a decision point and then have one branch to go somewhere else in the program. In other words, just take my words for it. If someone uses flowchart extensively to represent algorithms, that person can end up with spaghetti code or code that is really hard to maintain as a result. The second thing that is not so good about flowcharts is, how do you edit an existing flowchart? Okay, well, if you have a flowchart that is already kind of involved, okay, so let's say we have a flowchart. Okay, let's say this. Exactly. It is difficult to do any type of editing because if you want to add one additional step, you have to move a lot of stuff around in order to make space for that one additional thing that you're adding. Okay, the more complex your flowchart is, the more difficult it is to change it, to edit, to update, to revise it. So these are the two reasons why we do not like flowcharts. And instead we use pseudocode. Pseudocode, the name pseudocode comes from two words. The first one is pseudo. What is pseudo? False, not real, fake. And code in this case means program code, okay, program statements. So pseudocode, is basically telling you that this is the kind of program that is not real. It cannot be executed by a computer. So what is the whole point of using pseudocode when it cannot be used by a computer?
Just because it can't be used by a computer doesn't can't be used by us. Might make it easy for us to understand.
Sorry?
Just because it can't be used by a computer doesn't mean it can't be used by us.
That is exactly the point. Very good. Okay. Pseudocode is not intended for people. It is intended for. Excuse me. I just flipped the logic. Pseudocode is not intended for computers. It is intended for people. Okay. It's intended for other programmers. Okay. People who develop programs. So let's go ahead and take a look at some pseudocode. Okay. What is one place you can find a lot of pseudocode? Wikipedia. I'm not kidding. You go to Wikipedia and you can look up many algorithms that are already done. So you go to wikipedia.org and then we can look up, some, really well-known algorithms. So we'll go ahead and look up, let's say, bubble sort. And here we have pseudocode. This is actually pseudocode because it is not going to work in any particular programming language. It is pseudocode. And the intention of this pseudocode is not to have it run on a computer. It's for other people to understand how to perform the operations. Are there any questions about pseudocode at this point? Or why we use pseudocode in this class? Now, pseudocode has a few attributes that are really useful. The first thing is pseudocode is precise. Okay, if I give you a pseudocode statement, there's only one way to interpret it. Okay, it will specify exactly one action to perform, and there can be no ambiguation. Pseudocode is like that. Pseudocode is structured. Structured, it's a little bit difficult at this point to explain what is structured, but if I want to tell you what is structured, I can give you one example that should show you what is structured. You look at your file system. Okay, let me see if I can change it like this. This is structured. In other words, one folder can contain an additional folder, and additional folders can contain other folders like this. This is what I call structured. Okay? One thing has to be properly contained within a container. That other container may be contained within another container. So you can have layers and layers and layers of constructs, but they have a very clearly defined relationship. That's what we call structured, and we'll see this again later on in this class. Pseudocode is concise. In other words, the density of logic is really high. In one page of pseudocode, I can put in a lot of programming logic. But on one page, if I use flowcharts, I cannot pack nearly as much logic onto one page of flowcharts. So pseudocode has a very high code density that makes it very concise. Pseudocode is language independent in two ways. It is language independent from the perspective of programming languages. In other words, I go here, I look at the bubble sort algorithm. I look at this code here. It is only telling me how to perform, the bubble sort algorithm. This is not C specific. It is not Python specific. It is not Lisp specific. It is just a way of doing things. So I can take this description here. I can manually translate it into C code. I can translate it into Java code. I can translate that into Perl code, Python code, PHP code, and so on and so forth. So that's why it is not specific to a particular programming language. The second thing is it is not specific to a natural language. Now, I understand that procedure, length, for, swap, if, then, and, these are all English words. Okay? But their pseudocode only use a very small set of words borrowed from English. In other words, someone with a different mother tongue, a different natural language base can easily learn pseudocode. There's no need to learn full English in order to understand pseudocode. And it is also flexible at the same time. In other words, you don't have to use a particular way of saying something. If someone writes in pseudocode this, I understand x is greater than y. But what if the next person is going to say x is greater than y? I can understand that as well. Okay, so pseudocode gives you some flexibility as long as the next